Hi guys, we're starting chapter 3 from today. So this is interpolation. In chapter 3 we are going to work on 4 techniques of interpolation. First one is Lagrange's interpolation, then Newton's divided difference interpolation. Then we are going to use forward difference interpolation, forward difference, and then backward difference. Okay, so all of these four, first two, they work for any kind of data set, any kind of given data set, and then there is a restriction for the second part, like data need to be equal at equal distance. So I'm giving you an example. First thing, look at this one. A census of population of United States is taken every year. The following table lists the population in thousands of population from 1950 to 2000. So 1950 to 1960, then 1960 to 70, 1970 to 80, 80 to 90, 90 to 2000. We can see these are at equal distance. So what will happen is we can use any one of these technique for this data set. Okay, but there is a restriction for these two. They always need your data set at equal distance, and these two you can apply them for anyone, any kind of data set, any data set. So these are the 4 techniques we are going to learn. Now before going to learn the techniques, we want to know what is actually interpolation. So what is interpolation? What is happening here? We know the value at 1950, we know the value of population at 1960, 1970, 1980, 1990, 2000. If you need, for any reason, if you need the population anywhere between these values, what you need to do, because it is not available for you. United States is not counting population every year. So if you want to find out what is the population between any two data set, what you will do is you will calculate mathematically using some techniques, and those answer will be approximate. Why you are using those approximate technique? Because there is no way for you to use the exact answer, to find the exact answer, right? So numerical techniques are those techniques we said there is always, the answer is always approximate, there is always error, and our goal is we want to keep the error minimum, right? So these are the 4 techniques which will give us the approximate population between the given points. So if I plot this data set, these are the points, and I am looking for, when I'm saying I'm trying to do interpolation, that means I'm looking for a polynomial which will agree with this data point and give me an approximate value of the function between these points, between these given points. So maybe for this function you can find a polynomial which is a straight line. Maybe you will find something like this, and that is your function. So what will happen? At this point the function will agree with your given data set, and between them it will give you an approximate value for the function, right? Okay, so we are using the formula of Weierstrass approximation theorem, which is saying, suppose that f is defined and continuous in a closed interval. So in a to b, function f of x is the black one, function is closed and defined in the interval, and then continuous and defined on the interval. Then for each epsilon greater than 0, there is a polynomial which is the px, the blue one, with the property that the difference between f of x and px is always less than epsilon. Epsilon is a very small number, right? So what is happening, if the blue one is px, black one is f of x, their difference is always less than epsilon. So they are actually very close to each other, right? Okay, so we are saying the problem of determining a polynomial of degree 1, we are here, the problem of determining a polynomial of degree 1 that passes through the distinct point x0, y0 and x1, y1 is the same as approximating a function f for which f of x0 is equal to y0, f of x1 is equal to y1 by means of a first degree polynomial interpolating, or agree with the values of f at given point. Using this polynomial for approximation within the interval given by n points is called polynomial interpolation. So what is happening? You have 2 points given. One is x0, y0, and another one is x1, y1, and you are looking for a function which will satisfy these 2 points and then will give you an approximation of what is happening between these 2 points. Okay, so this is linear interpolation. Now we are going to work on any set of given values. So this is, we are starting with Lagrange interpolation. We are saying we have x0, x1, x2 up to xn. That means x0 to xn, total n plus 1 point. So what is happening? x0, y0, x1, y1, and so on, xn, yn. So you will have total n plus 1 data points. F is the function whose values are given at these numbers. Then a unique polynomial p of x of degree at most n. There are n plus 1 point. Your polynomial will be of degree n such that f of xk is equal to p of xk. That means at these points, at these given points, function value and the polynomial values will be same, and then between them it will give us an approximation of what is happening there. So the polynomial is given by some term L0 times f of x0. What is f of x0? That's y0, right? Because y is equal to f of x. So that will be some term L0 times f of x0, then L1 times f of x1, then Ln times f of xn. Now this f of x0, f of x1, these are x0, these are y0, y1 up to yn, and these are known. So we just need to find out these L0, L1, L2 up to Ln for all the n plus 1 points. How can we find that? So there is a pattern for this one. This is the formula for finding those values, and there is a pattern for this one. So how the pattern works? I will show you guys how the pattern works. It is not actually that hard. Okay, so look at here. This is saying when we have a linear function, that means I will have only 2 points, x0, y0, and x1, y1, and I want to calculate L0 and L1 for this point. L0 for the first point, L1 for the second point. So what is happening when you are calculating L0? On the top you have x minus x1, x0 is not here, and in the bottom x0 minus x1, right? When you are calculating L1, x1 is not in the top, dividing by x1 minus x0. So if you can figure out what is happening, then what is happening, p of x is equal to L0, which is here, L0 times f of x0, which is y0 given, plus L1 times f of x1 is given here, and then that will give you a polynomial. So let me show you guys for this specific problem. We have determined the linear Lagrange interpolating polynomial that passes through. The first point is 2, 4. So my x0 and y0 is this one, and x1, y1 is the second point. Okay, if it can be also given as a table for you. So x, y are 2, 4, and 5, 1, right? Okay, now first thing I need to calculate is L0. What is L0? X minus, we said x0 is not in the top, x0 minus x1 dividing by x0 minus x1. Okay, and what will be in L1? L1 will be x minus, x1 is not in the top, so x0 dividing by x1 minus x0. So So right now you just need to put the values. X is any number, x is any variable. So x minus what is x1? x1 is 5, x1 is 5, and then x0 minus x1, so 2 minus 5, 2 minus 5, okay. And then what is this one? X minus x0, x minus 2, and then x1 minus x0, 5 minus 2, 5 minus 2, okay. If I want to simplify a little bit more, that will be x minus 5 divided by 2 minus 5 is negative 3, and then this one will be x minus 2 divided by 5 minus 2 is positive 3. Now what is your polynomial? P of x is equal to L0 f of x0, which is actually y0, and L1 f of x1, which is y1, okay. So L0 we already found, x minus 5 divided by negative 3 f of x0, that means y0 is 4 times 4, plus L1 is x minus 2 divided by 3, f of x1 is y1, which is 1. So if I simplify, what will this one give me? P of x is equal to 4 over negative 3, right? 4 over negative 3, 4 over 3 negative x minus 5, and then plus 1/3 of x minus 2. If you want to simplify more, you can simplify more. If you want to keep it like this way, you can also keep it like this way. So what is happening? This one is giving you a polynomial function for any value of x. So suppose this one is giving between 2 to 5. The points are given at x equal to 2, y is 4, at x equal to 5, y is equal to 1. Now if you want to find out what is the function value at x equal to 3, so what is P of 3? So you will simply replace x by 3 in this relation. 3 minus 5 is negative 2, plus 1/3 3 minus 2. 3 minus 2 is 1, right? So you will just replace x by 3, and that will give you the value between anywhere between these 2 points. Okay, so your polynomial is, your answer is this one. And if you want to find out the polynomial or function value specifically at any point, you will replace the value of x by the point. Okay, so this one was a linear polynomial interpolation because we don't have any power in x. So this is a linear function. Right now I am going to work on the next problem. So you can see the next problem have 3 points. So what are the points? x0 is equal to 2, x1 is equal to 2.75, x0 is equal to 2, x1 is equal to 2.75, x2 is equal to 4. Find the Lagrange interpolating polynomial for f of x is equal to 1 over x. So when x is equal to 2, f of x is 1 over 2.5. When x is equal to 2.75, 1 over 2.75 is 0.3636 something. When x equal to 4, so we use this function to create this table. When x equal to 4, 1 over 4 is 0.25, right? 1 over 4 is 0.25, so there is a printing mistake in this one. 1 over 4 is 0.25. Okay, now what is happening? We want to find a polynomial, Lagrange polynomial for this one. So we can see we have x0, x1 and x2. So we need to calculate L0, L1 and L2 for each of the point. Okay, on top we said when we are calculating L0, on the top x0 is not there, so x minus x1 and x minus x2 dividing by x0 minus x1, x0 minus x2. So what is happening again? On the top, x minus, it will not have x0, everything else. So x minus x1, x minus x2, it does not have x minus x0. And in bottom, you are finding the difference from x0 to other points. So x0 minus x1, x0 minus x2. Okay, the same pattern for L1. So on the top, x1 will be not on the top. X minus x0 and x minus x2, and we will subtract from x1 minus x0, x1 minus x2. Okay, right now we want to calculate L2. So in the top, x minus x0, x minus x1, x minus x2 is not in the top, and then in the bottom we will subtract from x2 minus x0, x2 minus x1. Okay, now we want to replace all the values. X is unknown. X is any number, any variable which is anything from 2 to 4, and then x1, x0, x2 are known values. So right now we are using them. X minus x1 is 2.75, x minus x2 is 4, right, dividing by x0 minus x1. So 2 minus 2.75, x0 minus x2, which is 4. This is L0, and then we are calculating L1. X minus x0, so x minus x0 is 2, x minus x2 is 4, and then x1 minus x0, 2.75 minus 2, and 2.75 minus 4. Then last one, we are calculating L2. So what is L2? L2 is equal to x minus x0, so x minus 2, x minus 2.75 dividing by x2 is 4, so 4 minus 2, 4 minus 2.75. These are the L0, L1, L2. So the top part is not going to be simplified. We can simplify the bottom part. Okay, so we will simplify these numbers here, this part, this one, and this one, but I'm not going to simplify the top one. So what is right now P of x? P of x is equal to L0 f of x0 plus L1 f of x1 plus L2 f of x2. Now this f of x0, which one is f of x0? F of x0 means y0. F of x1 means y1. F of x2 means y2. And we have calculated L0, L1, L2 here, right? So right now we are simply going to multiply x minus 2.75 times x minus 4. What is on the bottom? 2 minus 2.75 and 2 minus 4. So 2 minus 2.75 is negative 0.75 times 2 minus 4 is negative 2, and then you are multiplying with f of x0. F of x0 is 0.5 plus L1 is x minus 2, x minus 4 dividing by 2.75 minus 2 is 0.75 positive. 2.75 minus 4 will be negative 1.25. right? Negative 1.25, and then multiplying with f of x1, which is 0.3636, 0.3636. Here is f of x1. Okay, then our last one is x minus 2, x minus 2, x minus 2.75, and then we are dividing. 4 minus 2 is 2, 4 minus 2.75 is 1.25, 1.25 times f of x2, which is 0.25. So times, we need to multiply with 0.25. So this is your polynomial function. Now if you want to find out what is the value of the function anywhere between 2 to 4, between these values, you will just replace x by that value. So if I ask you what is the value at f of 3, so look at here, this question is saying if you use this function, f of 3 is 1/3, but if you want to find out what is f of 3 in this polynomial, you need to replace x by 3, right? So you will replace x by 3 and complete the calculation, and that will give you what is the value of this function at x equal to 3. Okay, so you will complete this calculation. Now I am going to the next one. So it is calculating the same thing, but you have more point. And why I am doing this? Because I want you guys to identify, I want to help you guys to identify the pattern for the L0, L1, L2, L3. Okay, so this one is saying find f of 4.0. These are the values of x and y. Okay, and you have this one we name as x0, x1, x2, x3. x0, x1, x2, x3. You have 4 points, so your polynomial will be of third order. And then third order, so that's why we are saying actually L3, L3. These are showing the order for the polynomial. You want to calculate L0. So what will be in L0? On the top, there is no x0, and in the bottom, everything will be subtracted from x0. So x minus x1, x minus x2, x minus x3, and then bottom will have x0 minus x1, x0 minus x2, x0 minus x3. Okay, if I want to calculate L1, then what will I have? In L1, there will be no x1 on the top. So x minus x0, x minus x2, x minus x3, and then divide by x1 minus x0, x1 minus x2, x1 minus x3. When I am calculating L2, x2 is not in top, so x minus x0, x minus x1, x2 is not in top, x minus x3, right? X minus x3, and the bottom x2 minus x0, x2 minus x1, x2 minus x3. Okay, then we are calculating L3. So when we are calculating L3, x minus x0, x minus x1, x minus x2, x minus x3 is not there, and everything will be subtracted from x3 in the bottom. x3 minus x0, x3 minus x1, x3 minus x2, right? So what is happening right now? X is any value from, so this one is working from 3, then 4.5, then 7, then 9, and you can see they are not at equal distance, right? 3 to 4.5 distance is 1.5, 4.5 to 7, 2.5, and then 7 to 9 distance is 2. So this is not an equal distance data set, but x will be anything from 3 to 9, anything. So that will give you an approximation of what is happening between these points. X can be anything from 3 to 9, and for that this polynomial will give you the value of the function at that x. So we have calculated L0. So this will be your L0. You will calculate it here. Then L1, then your L2, then your L3. And f of x0, f of x1, f of x2, f of x3 are given. So these are the values. Okay. So right now, let me work more for you guys. X minus x1, x minus x1 is 4.5. x1 is 4.5. X minus x2 is 7, x minus x3 is 9, and then we are dividing by 3 minus 4.5, 3 minus 7, 3 minus 9. That will be your L1, L0. Okay, now we are calculating L1, x minus x0. So x minus 3, x minus 7, x minus 9. We will divide by 4.5 minus 3, 4.5 minus 7, 4.5 minus 9. Okay, then what is your L2? X minus 3, x minus 4.5, x minus 9, dividing by, simply we are using the values, these are the x values and these are the y values. Okay, so x minus x0, x minus x1, x minus x3, we are dividing by x2 minus x0. x2 is 7, 7 minus 3, 7 minus 4.5, 7 minus 9. Last one, L3 is x minus x0, so x minus 3, x minus 4.5, x minus 7, dividing by 9 minus 3, 9 minus 4.5, 9 minus 7. Okay, so right now you need to, the top part will stay as it is. You can only simplify the bottom part if you want. 3 minus 4.5 times 3 minus 7 times 3 minus 9. So you can simplify this part. Then on the polynomial, when we are trying to find the polynomial, what we are doing, p of x is L0. We calculated L0 here. This is your L0, right? You need to multiply this L0 with f of x0. F of x0, what is f of x0? 2.5. F of x0 is 2.5. That's given. F of x0 is 2.5 plus L1. So here will be your L1 times f of x1. Your f of x1 is 1.0 times 1.0. L2, you will calculate L2 from this one, times 2.5. L2 times 2.5, and then L3 times 0.5, right? L3 times 0.5, 0.5. So this is your polynomial in terms of x, because L0, L1, L2, L3, right now they are in terms of x. Now this is saying you find f of 4.0. That means in this polynomial you need to replace x by 4.0. So if you replace x by 4.0, you need to calculate the polynomial. Find the polynomial first and then replace x by 4. Okay. That will give you what is the value of this function at x equal to 4. Okay, I am not completing the calculation, this calculation for you guys, so you need to complete the calculation. And that's our interpolation method. Then we are going to Newton's divided difference interpolation. So you will find a complete worksheet for this one. So I'm going to complete this one for you guys and upload, but this is the video for you guys for Lagrange interpolation. Rest of the technique, divided difference forward and backward, I am going to upload them in a different file. Okay,